So, welcome to this second session of cloud data engineering, where uh, like day before yesterday, we discussed the initial big data emergence of big data technologies and how the distributed computing came into picture and how the Spark, how after that, slowly we have discussed a little bit on what are the limitations of Hadoop and all. So today we will, start from there. We will see the overall like architectural point of view, how the Spark and PySpark things gets evolved. And after that, in the second half of this class, we are going to set up our first Databricks account so that we all can have access to Databricks, and we will have an initial one round of introduction to the initial workspace and all. Okay, so all good. Let me share my screen real quick. Let me know if you guys are able to see it. Okay, perfect. So as we discussed in our last class, right, that Hadoop kind of, imbibe the distributed architecture where storage and computation all kind of gets distributed, and there is a concept of master node and data node where kind of all the master nodes are um, kind of all the master nodes dictate or monitors the data nodes, and in master nodes we have seen how the clustering and how the storage part gets handled. So again, we have seen there is three part of it. One is the cluster part of the Hadoop framework, which has been handled by Yarn. Second is the storage part, which is being handled by HDFS or Hadoop Distributed File System. And the third one is the compute part, which was initially being handled through MapReduce. So what you observe that MapReduce consists of two programs, right? Mapper and Reducer. But while we are executing those MapReduce jobs in the Hadoop framework, the overall performance of the system was very slow. Okay, to run a single MapReduce job, there are times it took around 30 to 40 minutes to execute some simple MapReduce job. So that was kind of a concern for most of these data engineers that time. Along with that, the ease of development, right? Mostly from in the database world, people used to understand in the language in form of SQL. But MapReduce initially was been written in Java. So we have to run or we have to code the entire logic in Java to execute those MapReduce framework. So that is kind of not kind of an easy task from the development point of view from for the data engineers, right? Next, that language support, as I discussed, like it's mainly through Java, and later half of the later half it came like Scala language came in. So again, Scala is almost similar to Java, and to code it, you have to execute a lot of lines of code to execute some small task. So that is kind of a redundant effort. Okay. And also from the storage point of view, though Hadoop comes up with HDFS and distributed file systems and all, but still there was some limitations on storage. It was not able to handle petabytes of data, right? So in order to handle petabytes and more data, there was a need to have a more robust system which can access and process those data storage part. Okay, and the resource management, as I already discussed, this is kind of being handled through Yarn from the resource management point of view. So in order to, come up with the fallbacks of Hadoop, Apache Spark come into picture. And since you guys all know, I'll not get into much deep into all these things because a lot of things you can, go through and, read the white papers and all. But at an overall, I'll just give you the concept, when and how Apache Spark come into picture, and what is the advantage of Spark over Hadoop or MapReduce to be very precise. So Spark, like it is from the performance point of view, Spark is kind of 10 to 100 times more faster, okay, with respect to any of the MapReduce job. And it gives a kind of both the option, it gives us both the option to write the code either through Python or Scala or through Spark SQL. So whoever is more comfortable in writing SQL SQL scripting, they went with the Spark SQLs. Whoever is more comfortable on any of the programming language, they pick either Python or Scala. Okay. So Spark is kind of language agnostic on this regard. Also, it has got a high performance SQL engine and it's compatible with different APIs. We can plug and play different APIs with this Spark framework, and then you can run this framework. So another advantage of Spark is the main reason why Spark, came into this picture was Spark, and you can integrate Spark either with Hadoop framework or with any of the cloud services. So if you name it, like be it AWS or Azure or GCP, okay? So the recent models, whatever has been, adopted by different companies, where the storage part, like let's say storage part is being handled by any of the cloud provider, be it Azure Blob or AWS S3, okay, those part is being handled by those cloud services, and the computation part, right? Computation part is handled by Spark. So you guys have to understand one thing: Spark doesn't come with any of the database. Okay, it's just provides the computation part or the transformation part of the data pipeline, and you can integrate the Spark with Hadoop. If you are integrating with Hadoop, then HDFS, Hadoop Distributed File System, is the storage layer which you can plug and run. And if you wanted to integrate with any of the cloud provider, you can connect it with S3 or Azure Blob and then execute your Spark pipelines. So it kind of gives us a kind of framework where you can link or attach this Apache Spark framework to either to the cloud or to the Hadoop structure. So that is the main advantage. Okay. And storage wise, it just provides only the computation part, and storage part is either being provided by cloud storage or an HDFS storage. Okay. And resource management point of view, you have the Yarn or Mesos, or in today's world, the Kubernetes and all, right? Those are kind of become very popular, which kind of handles all the resource management part of it. Okay. So so that's why Spark, initially it was being used replacing MapReduce, integrating with Hadoop, but slowly now Spark is more used in integrating on the cloud data engineering pipelines. Okay, so when we are integrating it with Hadoop, we are calling it as a data lake. So these two terminologies are quite often used in the industry. So data lake and lake house. Okay, I'll quickly come into those two concept. So when we are integrating Spark with a Hadoop platform, we are calling it as a data lake. Okay. And if we are integrating with the cloud platform, we are calling it as a lake house. So this is more of an like high level, overview of Hadoop, big data, Hadoop, and then Spark, and how Spark, we can integrate Spark with different cloud storage service. Okay. So once we have Spark, we can compare the performance of Spark with Hadoop and any of the relational database, right? So if you just quickly, compare both the approaches, okay, where in one side we have a traditional data warehouse kind of system. Whoever has worked on ETL or has worked on any of the database might correlate this. So in any ideal, ETL or data warehouse environment, we have a ETL layer where we kind of, extract the data from different sources. We kind of transform it and then load the data in the central data warehouse repository. Okay. And there, most of the time, let's say if you consider Teradata or Netezza, those are kind of an typical data warehouse system where we kind of have huge servers in different parts of the world and where data gets, stored. So as we already discussed in our last class, so if we have to, increase the kind of computation or storage of this particular framework, there is no other option to, you have to bring that server down and make the necessary adjustment and then again bring it up. So that is kind of the functions we had in the data warehouse environment. So the main problem it is like this is called vertical scaling, right? So we are scaling it vertically. So the main problem is it is time consuming, and there are a lot of systems which you cannot make it down for, let's say, 1 hour, 1.5 hour. There are various mission critical applications that are there. So in that respect, this typical approach where we are using the data warehouse has some fallback. So compared to that, in Hadoop, we had kind of an distributed processing. All the data are kind of distributed across all the worker nodes, and we have, if any other worker nodes are kind of falling back, we have data replicated in any of the secondary nodes. Okay, so let's say if any particular node gets down, we have a fallback. We have a secondary node which is already available, which will kind of act as a primary, and so there is always a data availability. So this Hadoop kind of framework will provide us Hadoop integrated with Spark, right? We are not talking about MapReduce or we are not talking about Hive now. So this kind of framework will always provide you the data availability 24 into 7. Okay, so that is the main advantage. Another main advantage was like it can handle petabytes of data, which was kind of a limitation in the classical data warehouse models, right? If you wanted to increase the storage and all, so any kind of Hadoop or cloud framework, right, you can use. And if any one of you are working in cloud, must be, you guys can correlate that the S3 or the blob, those are kind of, it's not that expensive. You can store 1000 GBs or terabytes of data with very minimal price. So in that respect, the pricing point of view also, the cloud data storage and the Hadoop data storage are kind of, getting tractions and getting more advantage on the with respect to the classical data warehouse. Also, there is one more thing like with respect to the data type, right? Uh, it can handle any kind of data type like structured, semi-structured, unstructured, all kinds of data types it can handle. So this is a typical architecture of a data lake. Initial architecture of data lake where we have a central part of the data lake. I hope you guys are able to see it properly. So if you see the central part, it's a data lake where data is getting consumed across different sources, structured, semi-structured, unstructured, all kinds of data are kind of loaded into the data lake, right? So after that, if you see there is an ETL part of it, right? So in the initial part of data lake, what used to happen is any of the ETL tool, name it, Informatica, or these days they call it IDMC, or ab initio, or data stage. Those ETL tools can kind of, capture the data from the data lake and execute a lot of transformations, okay? And again, load it back to the data lake again, okay? So that is kind of the initial kind of design that they came up with. And then on top of data lake, there are different reporting applications. If you see the upper half of that architecture diagram, right? So there are different BI reports and different machine learning models, data science models. These are kind of directly used to capture the data from data lake. So that was kind of an initial architecture of data lake. But the main problem was, though we are fetching the data, doing an extraction, transformation, and loading. Main problem was it has some fallback, or it has some limitations from the reporting point of view. Okay, so if you guys, any of you guys have worked on any of the data warehouse environment, you guys might be knowing there is a concept of data mart, right? We have to create dimension models, fact models, and then link those models in the data warehouse, and then we can create different reports on top of it. So though the earlier version of data lake was, having those limitations. So now after that, there was a slight change in the architecture that happened, where now the ETL part, they are fetching the data. The ETL means any kind of ETL tool or any kind of Spark processing, right? You can consider PySpark transformation is also one of the ETL operations, right? So the bottom half of the bottom layer consists of data lake, where we are getting the data across different sources, storing it, and from there, ETL is kind of grabbing the data, and then they are kind of using the data for different kinds of transformations. And then instead of loading it back to data lake, it kinds of loads it into the data warehouse, the typical data warehouses. So once the data gets loaded, after that, there are different BI reports, right? You name it, Tableau, Power BI, those two are kind of market leaders. But nowadays, AWS Lookers and all, those are also getting good tractions. So those reports, those reporting tools are kind of pointing to the data warehouse and build the different kind of reports which is required for business. Okay. Along with that, there are different data science and machine learning models which are kind of fetching data from the data lake and then building their models. So this is kind of a data lake model that currently is being used heavily in the industry. Okay, so and this is the overall architecture, and from the data lake point of view, this is how the different segments of the uh, systems are being handled. Okay, so any question till now, whatever I have discussed till this point, you guys have any question?
So you said so fact dimensions used in our earlier ETL processes. Nowadays we don't use those concept.
So dimension and facts are used in, not in ETL. It's been used in data warehouses.
Okay.
Okay, so data warehouses, typically what happens, you will have, let's say you imagine a particular application where you have to create different dimension tables and fact tables, right? And those are kind of integrated with their referential integrity, like primary key, foreign key, references, and then this will kind of create a snowflake schema, right? Whoever knows the star or snowflake schemas and all, so those data model or those tables exist in data warehouses, right? But in order to load the data on these tables, be it dimension table or it fact tables, so you need to, in between this, there is a ETL process, right? So those ETL pipelines kind of fetch data from source, like raw data, right, from the source, and then use their transformations based on the business logic or business rule and load it into the dimension and the fact tables, which sits on the data warehouse.
Okay, got it. Thank you. Basically, those are the structure which data fetched through ETL will follow to get stored in data warehouse.
Correct. Yes, correct. Okay. Anyone else? Till this point, we are all clear?
I don't think that's how it's being done anymore, though. And I think that was
Right.
the original question, right?
I'll come, India, I'll
Okay.
come. Yeah.
Yeah, thank you.
This is the data lake architecture of it. Okay. But nowadays, we have a lake house and more advanced feature. We'll come to that. But I just wanted to understand, want you guys to understand how the data lake framework is being, executed and done. Okay. So this is kind of the process where data lakes and, initial days of data lake formations, the datas are structured, semi-structured or unstructured datas are kind of, fetched, loaded into the data warehouse and then build their pipelines to load it into data warehouse. Okay. So this is kind of the initial version of data lake that we can think of. Okay. So now, before jumping it in onto lake house and the most modern technologies or the architecture that these days are being followed, so I'm going to quickly go to my uh, browser, and then we are going to, I just wanted to, show you guys like how we can set up the Databricks free edition. Okay. Before that, any one of you used Databricks free editions or community edition earlier?
Yes, I did.
Okay. Okay. Is it Arsenal?
Arsalan, yes.
Okay. Sure. So Databricks initially had a kind of a community edition, okay? But now it has come up with an concept of free edition where it integrated a lot of its AI features and it has integrated a lot of other features. So they have recently introduced this free edition concept. So even if you are using any of the community editions in Databricks, this will slowly go away, and the free edition part will kind of will be used across the industry. So if you just go to Google and you just type Databricks free edition, okay. So there are two things. Okay, don't type Databricks free account. Okay, it will give 14 days of trial account and all. We don't need that. We need to have the free edition. So if you just go and type free edition and hit enter, you will get the first link, right? This will give us the first link where I'll just go here. It's super simple. It's just 2 to 3 steps, and then we can set up our free edition part. So here it's saying sign up for free editions and login. Okay, so we can click on the sign up for free edition. Okay, so we'll just click here. Okay, so this particular page will come up where it will ask for Databricks free editions, and these are the things, blah, blah, blah. And then we'll ask for sign up for free editions. So we can click on continue with Google, okay? Or if you want to use any other email, you can use it. So if I click it here, it will route me to my different accounts. Okay, so since I have this account set up, you just need to use any of your Google account, and then there will be a code that will be sent to your mail. You just have to give that code and you will be all set or all done. Okay, so this is that simple. Okay, but only one thing is, I just wanted to highlight, whenever if you guys, if any of you are using Databricks Community Edition earlier, so there are some differences, that some additional features that Databricks has added here, and there are some code, right? Some code that we used to run in our Community Edition and that used to run properly. Now there was some limitations, like we cannot run certain codes and certain features there because they have introduced some new concepts and some serverless compute and all. But mostly 90% of the code will work as is, but there are some code, some portion will not get executed in our free edition. So we will have to, check, and we'll have to tweak our code a little bit to work in that free edition. Okay. So if you see, so this is kind of the, whenever we will kind of logged into the register ourselves to the Databricks, this particular page will come up. Okay, so this has given, and Databricks has given a lot of features here. So there are a lot of explore starter projects, and there are different courses that they have mentioned. So these are all given by Databricks, to just to set the level up here. Okay, and here you can connect your data. There are a lot of features they added. You can upload data from your local system and load the data, browse public data set, and then just connect to 50 plus data sources, right? So Databricks, through this you can connect to different AWS, Salesforce, SAP, and different source systems or whatnot, and then use it. So this is kind of the home page. Now if you see the left hand side, the first one is the workspace. This is kind of the main workspace where we are going to, whatever code we are going to write, whatever transformation logic, okay, we are going to build it here. Everything will come here. Okay, so there are different features. Again, lot of things are not present in the community editions. Now they have added it. Okay, so if you see in the workspace, under this there are different features they have added. One is repos. Okay, so through this, I guess you can integrate with any of your GitHub. Okay, then the second part is shared. Okay, if we have to, this part I haven't explored much. I have to check how we can share, if we can share any kind of folder or data set or code based to different system altogether. So but they have included this. This is the shared part, and then the user, right? Under user, so this is the user, or the email ID through which you are kind of getting logged in. Okay, and then again you can bookmark any of your favorite codes and all, and this is kind of a trash things. Okay, so now whatever code you are kind of we are going to build, we are going to use, everything should be there under your workspace. Okay, under this workspace, all the files, folders, different notebooks, everything will reside here. Okay, and whatever notebooks you will be using, there is another section called recent. Okay, in the recent section you will get to see all the notebooks and all, whatever will be using. Okay, next is the catalog section. Okay, now what is catalog? Again, we will discuss in depth in the course of this journey. But overall, what is catalog? Catalog is nothing but an environment, right? So now in this free edition, Databricks comes up with this concept. Under catalog, we can create different databases, schemas, okay, and we can use those tables, schemas under these different catalog. You can create your own schemas, own databases. You can rename it, and then based on that you can use this. So earlier in the community edition, there was a concept of DBFS, database file system. Okay, so all the files, whatever file we would be working on, like whatever notebooks we will be working or will refer those files. So most of them used to reside in DBFS. Now, like DBFS stands for Databricks file system. So now they kind of get rid of this concept, and now they came up with this catalog thing. So we will explore more on this, how to create tables, how to create schemas, and how to use these tables and schemas from our notebook to this part. Okay, so we will explore this. Now there is another feature here under Databricks is jobs and pipelines. You can create some ad hoc jobs, some different pipelines, be it batch processing or data streaming, okay, real-time data processing. Through that, you can execute the jobs, you can execute the pipelines and all those things. So these features, they keep on adding different kinds of features here, and we will explore all these, okay, how we can use this. Next is compute. So the compute part this is kind of the heart of Databricks, right? Whenever we will create a notebook, we will write our code, okay, transformation code through PySpark, right? So we need to have some compute engine to execute those jobs, right? We need to have a compute engine. So earlier in the community edition, we used to create some cluster, okay, and then we can tag those cluster in the notebook. So if any one of you are like most of you, I know this is pretty new to most of you, but I'm just giving you a reference, right? So let's say this is one of an example of a notebook where there are some series of code, sequential code, the transformation code that has been written. Okay, so earlier what used to happen, this section this section there was some concept called compute, where we can create our own cluster, okay, and we can tag this cluster to this particular notebook, so that when we run it, you guys will be able to see this run small button, right? So if you execute this particular cell will get executed. So in order to execute any particular cell, we need to tag this compute engine. So the major difference that currently they have come up with is they have come up with a concept of serverless warehouse, okay? So this serverless warehouse, because of this, you can create your, you can, similar to this, right? Compute engine, you will create compute engine and you will tag to it, okay? You will tag any serverless compute engine here. Now, the major thing is when in the classical compute engine, you can create data frames, you can create tables, and then you can execute those pointing to different file system, be it Parquet, be it Avro, okay, be it Delta. So these are different file systems. I will in depth I will discuss those file system, how how they differ from each other. But I'm just giving you guys a concept like how it differs from the community editions and all. But now in the new free edition, we cannot create any data frame pointing to Parquet. Okay, so the requirement is like in most of the cases, all the Parquet data sets or Avro data sets has to get converted into a Delta Lake or Delta format file, and then from there we can create our data frames or manage tables. So those things we will check, we will discuss in detail. Okay, so these are the main tabs. After that, they also introduce, there is another section called SQL. Okay, so as you know, Databricks, though it provides an integrated concept of where all the transformations and everything, we can run it in the notebook, it again gives us a flavor of SQL. All the features, most of the features, whatever we are writing it in Python, you can write the similar thing in SQL also in Databricks. So it has come up with some unique concept of SQL editor, okay, so where you can directly query some of it, and then you can directly query the tables or their file system through this, and then this is the query engine, and then this new feature, dashboards. You can create some dashboards out of it, okay? You point to different table and then you can create a dashboard, okay? Then this concept of Genie, alerts, you can create alerts, okay? And also the query history part. This is pretty awesome, right? There are times when we run certain queries and it kind of, stores all the already executed query. in the pan, and then so that you can refer these queries at any point of time. And then it comes with SQL warehouse. Similar to the serverless warehouse that has been provided here, it also has a serverless, SQL warehouse, where whenever we kind of execute those workloads, execute the transformations, you can refer to that. Again, size also, since it's a free edition, we are not having much options, but normally it has, depending upon the size, the costing and the execution power will vary. It starts with, let's say, X small to 3x and the 4x, and based on the capacity of the increase in capacity of the compute size, the overall costing and everything will kind of gets increased. So these are kind of the high level SQL part. Okay, first is this, then they have introduced the SQL part, and then this is the data engineering landscape, the job runs, right? Whenever we will build our some workflows or build our pipelines, and then let's say there are some transformations rule you have written in 3 different pipeline, and you wanted to execute those jobs or notebooks, right? So through this pipeline you can execute, whether you have to execute the notebooks sequentially or parallelly. So all this process you can use it through that job runs part. Okay, and there is again another part is data ingestion, where you can ingest certain data. Okay, and this is a very beautiful addition of Partner Connect, where, as you know, right, in any of the enterprise, data doesn't reside only on one part silo, right? So it would be there in Salesforce, let's say any of the customer centric data. Okay, any of the, if you wanted to forecast any sales, everything would be there in Salesforce, right? SAP, again, depending upon the different modules, whether it's a supply chain, sales and planning, and then material, depending upon the module, right? All the data you can integrate. Okay, those data you can fetch the data and then you can integrate. Again, it has an connector with Workday, ServiceNow, Google Analytics. Lot of options they provided, though it's not practically not possible to check and implement everything, but it kinds of gives us a holistic platform where we can use it, write our code, write our transformations, and then execute it, and then use it for our downstream reporting or any of the process or ML AI processing and all. Now the last part, right, which is very awesome, the AI/ML part. They are kind of slowly integrating the AI/ML part of it in Databricks very well. And Databricks is now coming up with a strong AI features. Okay, all the Gen AI capabilities. Okay, they are coming up with different models and integrating it very well. So we will get to see this. So these are kind of, though this course will not going to discuss all these in detail, but this at a high level, this is giving us like the AI/ML capabilities of Databricks. Okay, to be very honest. So I'm just giving you an small overview. So let's say this is one of the notebook. Okay, so if you see in any of the community edition, these things are not there. So now they have integrated. So edit code with assist. Okay, let's say you are writing a code, and there are times it happens, right? For any of our for us, like whoever is developing any code, it's not possible for us to memorize all the lines of code, right? So this will give us an advanced feature where we will just write the skeleton structure. Okay, and even if there is some small mistake, syntax mistake or something happens, this code will this code assistant, okay, this will kind of help us to guide where exactly the error happens and how to navigate and all those things. So this is the very beautiful feature that they have integrated. Earlier it was not there. Okay, similar to that, I guess there is one more feature. So this one, right, open focus mode. If you click it here, so let's say you are writing a 10, 12 or 30 lines of code, and it will give you a feature like it will give you a feature like you are writing it in any of the ID. Okay, and these things you can, execute. And again, you can come out of this focus mode, and then this will be kind of one. Okay. Also, another beautiful feature which was already there in the community edition, I'm just highlighting it. Okay. So whenever you will open a notebook, okay, this kind of things will do. Each of this section is called cell. Okay. In this cell, we will write our code. What we are going to write, I will discuss in detail from next class, stepwise. Okay. What we are going to achieve, how we are going to write. These would be mainly Python, PySpark codes. So now if you see, since we are using a Python code here, this is written here Python. Okay. So if you click it here, you will get this 3 to 4 different options. Okay. So instead of Python, let's say if you want to write any SQL, let's say you have built a data frame, and from the data frame you are creating a table. Okay, so you have created a table in the same notebook. In the second, let's say you have created a table or a data frame and then a table, and then in the next section, in the next cell, you can use that table in form of a SQL. So it will just give a %SQL, so that now the code, the interpreter will know now this is no more a Python code. It's an SQL code, SQL scripting. So now we can write select star from those table and any of the SQL syntax that you can write, and you'll be able to see this button, right? This play button. This is nothing but the run cell. Okay. Whenever we will execute this particular cell will get executed. Again, there are plenty of other features. This is only to execute a single cell. Okay. If you want to execute the entire cell in that notebook, you can use this run all feature. Okay. So you can execute this run all, and then all the consecutive cells will sequentially get executed. Okay. So one more thing, whenever we create a notebook, first thing we have to do is we have to tag this to a serverless cluster. Okay. So this is a serverless cluster. We'll just have to tag it, and it will, now it's saying connecting. So what does it mean? It means like we are connecting this particular cell. We are connecting this particular cell to this particular notebook, to this serverless cluster. So once that is done, and then we can execute it. Let's say we are executing this piece of code. Again, what is this code and all, I will explain, okay, in detail. Just say we are executing a run button. Okay, so it's getting executed. Okay, no. So it's saying interrupt. Okay, so it's kind of executing, and once it gets executed, it will let us know whether the code is successful, whether it is able to execute the steps or not. And also, yeah, so this means that it has successfully executed the code, and it have created a particular data frame. Okay, how we are creating a data frame, what is this option, I will discuss in detail. I'm just giving an overall high level idea what are the things that are there. Now let's say we are writing it. Now we need to create a new code, new cell, right? So the option is we have to there are two ways we can do that. So this is the code. Now after that we wanted to create another cell. So how we can do that? We can one way is we can click on escape and then B. Okay, escape and B. If we do an escape and B for below, so it will create another empty cell. Now this cell is by default. Databricks will have a Python cell. Okay, but you can anytime you can change it to SQL. Mainly we'll use Python and SQL here, but you have a provision to use Scala and R also in this code. Again, let's say you wanted to, so Python is the notebook default. You can use SQL, and again you can use Scala and R. Now, what is this markdown? Markdown is nothing but if you have to write any comments, right? So writing code is one thing, but you have to write specific comments, like what this code is doing, right? What is my first cell is doing, right? What is my second state? All those things we need to document it, right? So if anyhow you have to, if you have to make it write any comment, you just make it as a markdown. And then you can write your comment. Okay, you can write your comment. So markdown is nothing but %MD. So this is our first Databricks PySpark code execution. Okay. So this will be in form of a comment section. Okay. So another way, so there is one way is if you wanted to toggle between the above or below cell, you can do an escape, and escape B will create a new cell below it, and escape A will create a new cell above it. See, this cell gets created. So escape B, escape A. This is how you can create your cells and all. Okay. Another way of creating it is you can here from this you can add comment, add title, and all those things also you can use. Okay. I am not sure, I am not getting this feature. We can add cell. Okay. Down title. There was an option here. Instead of escape A and escape B, we can add cell above and add cell below. Here you go. Okay. So these two options also you can use so that you can, create a new cells and then use those cells here. So that is kind of and then again, there are other options that are present. These code assistant, whenever you'll get some syntax error, or if you need any guidance on your code, you can write it. It kind of use as an co-pilot or GenAI assistant, which will help us. It will not write your all the code end to end, but it will kind of guide you. If you know the coding, if you know what exactly you are trying to do, it will kind of act as an guide to just like any other typical AI tools that these days are doing. So it will kind of enhance our capabilities in building the pipelines. So this is overall at a high level. Okay, creation of Databricks free account and all. I would highly recommend everyone to set it up in your system. It's a pretty simple process. Set up your workspace, and then in our next class on Friday, we are going to start our first line of code. We are going to execute some notebooks and execute the data, and we will see how it works. Okay, any question, guys?
Yeah, I don't see Java in your language list. So Database should support Java, right?
I think so. To be very honest, Masood, I haven't seen anyone using Java in Databricks. Maybe I haven't seen it, but you guys let me know if you've seen. But mostly, what in my experience, mostly Scala and Python. Python is mostly used. There are times Scala is also used. These two are the languages that are being highly used. Even not even R. R was kind of, R is also not
It is
being
data
heavily used.
analytical language. I mean, it's a statistical
Right, statistical
analysis.
things and all, but mostly, if you ask me, in industry, Python and Scala, these two are being used, and also SQL. Don't forget about SQL. It is also heavily
Yeah,
used.
is the core.
Yeah.
I have a question. To get the Databricks certificate, do we need to know the AI and ML?
Good question, Arsenal. So Databricks certification has a two-part, right? One is Databricks certified associate data engineer. There is another Databricks certified practitioners. In these two areas, it's mainly focused on data engineering part of it. Okay, so for that, AI is not required. AI is not needed. Okay, but there is one more certification that Databricks has come up with, which is called GenAI, Databricks Certified GenAI Professional. Okay, where it has a it will ask that it's an extensive or exclusive for MLAI or GenAI capabilities of Databricks.
Okay, so according to our job or to our background, which certificate do you suggest?
Yeah, Databricks Certified Associate Data Engineer.
Oh, okay, thank you.
Yeah. But again, having said that, the sky is the limit, right? Associate data engineer it will give you a core, base. You will get a lot of job opportunities through that certifications, and if you have a good solid background of Databricks. But after that, slowly you can, get that certification also, GenAI certification also. So these two will kind of, will give you will give your CV more, impact.
Oh, I see. Thank you.
Yeah.
So do you say is Databricks associate data engineer? Say
Is
that
it
again.
Chris? Chris, could you please be louder? I'm not able to hear you.
Okay, I'm asking the certificate you mentioned. What is it the Databricks associate data engineer or
Right.
Databricks
Database certified associate data engineer. Right.
or certified? Okay.
Sorry, I am getting difficulty hearing you.
No problem. I got you.
Yeah. Thank you. Any further question? If not,
Okay. My question is
hmm,
because I can see you are on Databricks actually. So do we have to create an account on Databricks?
do you have to pay some amount?
Create account on Databricks.
Right. We have to create it. Yeah.
Because I can see there is a Databricks, Azure Databricks and AWS Databricks. So, but are we doing that via Azure account or are we have
No,
to
no,
go?
no, no, no. So we will use this Databricks, all these features, whatever you are seeing, we will use this Databricks free edition through that. And after that, in the later part of the course, we will use Azure service to connect to those Databricks. Okay. But
Okay.
for now, we will concentrate on this Databricks free edition, and it will give you 1 year free use of 1 year free. Again, you can use it after 1 year. You can use separate email ID and you can use it. So it's kind of you can use it anytime, and it's absolutely free. You don't have to pay anything.
Okay.
Anand, I have a question. So, when I asked the DeepSeek for, you said Spark on Hadoop is like data lake, right? And Spark on
Mhm.
Cloud is Lakehouse, right? You said that.
Right, right.
But DeepSeek says that no, it's like data lake itself is Spark on Spark on Hadoop. Lakehouse is Spark plus Lake on Hadoop.
Right. So basically, Lakehouse is the more advanced concept where uh, apart from this, instead of using HDFS or Hadoop distributed file system, they are now using the cloud storage services. Okay, cloud storage services of this. So you are integrating Spark with the cloud services here in the Lakehouse.
Okay, still Hadoop is there, right?
Still, Hadoop is there, but if you see, like most of the time, in most of the organizations, Hadoop is kind of, going away. So it's mostly now the cloud services, either Azure or AWS or GCP with Spark.
Okay.
Okay, all right. So same time, Friday, we will, start discussing start writing the codes, and we will, take it from there. Okay. Thank you. Thank you, guys.
Thank you very much.
Okay,
Thank you,
thank you
guys.
very much.
Thank you.
Thank you.